So we are going to start remaining questions of exercise 1.2, right? So we did question number 1 and 2, right?
Yes, sir.
Now see question number 3. Prove that greatest integer function f r to r. So here function is f r to r. That means domain is real number and codomain set of real numbers. And define as fx equals to greatest integer x is neither one nor on टू. ना ही ये वन होगा और ना ही ये ऑन टू होगा. चलो सबसे पहले वन चेक करते हैं. Check first 1 1. So in question already it is given it will not be 1 1. So we can take example, right? So here 1.2 and 1.3 belongs to domain. Domain means real numbers. Now f 1.2 will be greatest integer of 1.2. Now greatest integer 1.2 will be what? First integer less than 1.2. So it is 1. And f 1.3 equals to greatest integer 1.3. This is also 1. So see, we have taken distinct element of domain, but we are getting same image, right?
Yes, sir.
So here what we are observing, therefore 1.2 not equals to 1.3, but f 1.2 equals to f 1.3. Therefore we can say that f is not 1 1. Okay, understood?
Yes, sir.
Now it is also not onto. That means we have to prove it is not onto also. So now check for onto. Now see all images of these greatest integer functions will be always integer. होगा ना? चाहे x का वैल्यू कुछ भी हो, बट उसका इमेज क्या आएगा?
Same.
इंटीजर आएगा, क्योंकि ये ग्रेटेस्ट इंटीजर फंक्शन है. तो कोडोमेन में तो हर टाइप का नंबर्स है ना, एनी रियल नंबर्स. ठीक
Yes,
है,
sir.
तो ऐसा कुछ एलिमेंट है जैसे कि 2.5 ले लो. 2.5 बिलोंग्स टू कोडोमेन, but 2.5 is not image of any element of domain.
Yes, sir.
2.5 is not image of any element of domain. इसका मतलब क्या हुआ? जो 2.5 has no pre-image in domain, that is 2.5 has no pre-image in therefore range not equals to codomain. क्योंकि रेंज सिर्फ क्या होगा? सेट ऑफ इंटीजर्स होगा, बट कोडोमेन क्या है? सेट ऑफ रियल नंबर्स.
Yes, sir.
अगर रेंज एंड कोडोमेन इक्वल नहीं होता है तो हम बोलेंगे देयरफॉर f is
Not on to.
not onto. अब आ जाओ क्वेश्चन नंबर 4 पे. अच्छा, show that the modulus function f r2r given by fx equals to mod of x is neither 1 1 nor onto, where mod of x is x if x is positive or 0 and mod of x is minus x if x is negative. Okay, so answer 4. Here f R to R. This is very important because from here we can understand what is domain and what is codomain. And define as fx equals to mod of x. First we'll check it is 1 1 or not. If we'll check 1 1, then consider 2 and minus 2. Sorry, here take two distinct element, it is better. Yeah, take 2 and minus 2 belongs to domain. Now f2 that is equals to mod of 2, its value is 2. F minus 2, this is equals to mod of minus 2, it is also 2. Therefore 2 and minus 2 are distinct, but their image are same. That means f2 equals to f minus 2. Therefore f is not 1 1. Understood?
Yes, sir.
Now check on 2. Now see here, always image you will get positive real numbers, either 0 or positive real numbers.
Yes, sir.
But in codomain, negative number also present, like minus 2 belongs to codomain. Any other example also you can take, but minus 2 is not image of any element of domain. It means minus 2 has no pre-image in domain. Minus 2 has no pre-image in domain. It means range not equals to codomain. If range and codomain are not equal, then you can say that f is
Not onto.
not onto, right?
Yes, sir.
Sure. Question number 5 also, similarly we can prove. It is signum function, right? So if you take like 1, 2, 3, every image will be 1 only. So it is many 1, it is not 1, 1. And here also a range contain only 3 elements, 1, 0 and minus 1. But codomain is set of real numbers. So range not equals to codomain. So it is not onto also. So I'm not doing question number 5. Okay, question number 6. Let a equals to given, b equals to given, and f is given, be a function from a to b. So that f is 1, 1. So question number 6. Answer 6. So here a is given, b is given, and f a to b. And f is 1, image of 1 is 4, 2 is 5, and 3 is 6. Okay, so if you draw ray diagram, domain and codomain. So this is domain and this is codomain. So here domain is A and codomain is B. Domain contain 1, 2 and 3 and codomain contain 4, 5, 6 and 7. Now image of 1 is 4. Image of 2 is 5. Image of 3 is 6. What you are observing? For all x1, x2 belongs to domain. If x1 not equals to x2, here you will write x1 not equals to x2, then fx1 also not equals to fx2. So this was the definition of 1, 1 function. If distinct element of domain if you consider, if you are getting distinct images, therefore we can say that f is 1, 1. But in question they are not asking it is onto or not. But if I'll ask to you, is it a onto or surjective?
Sir, it is onto.
How? If onto, then range and codomain should be equal. Are you getting? Range and codomain equal? Range contain only 4, 5 and 6. But
Yes.
codomain contain 5, 4, 5, 6 and 7. So range and codomain are not equal. One
Yes.
element is free here. 7 is free here.
Yes, sir. It won't be equal to.
Yes. But in question they are not asking. But if in question they will ask check onto also, then you will say since range not equals to codomain, so it is not onto. Okay, fine. Question number 6 we did. Question number 7. Very good question it is. If function is linear function, then always it will be 1 1 also, on 2 also. One question I am showing to you, other questions you will do by yourself. In each of the following case, state whether the function is 1 1, on 2 or bijective. Justify your answer. So first one I am showing you, f r to r, and defined as fx equals to 3 minus 4x. You will remember, if it is a linear function, then always you will get it is 1 1 also, on 2 also. How you will prove? 1 1 for all. Here example is not allowed. x1, x2 belongs to domain. If fx1 equals to fx2, then fx1 you are getting 3 minus 4x1, and fx2 you are getting 3 minus 4x2. From both sides 3 3 cancel, minus 4x1 minus 4x2. Minus and minus also you can cancel, 4 and 4 also you can cancel. So what we are getting?
X1 is equal to
x1
x2.
equals to x2. This was the definition of 1 1 function. Therefore, f is 1 1. Right.
Yes, sir.
Now check on 2. So in this type of questions, let y be any element of codomain. Now if we get image, pre-image of y, then we can say that range equals to codomain. So here y equals to fx, so y equals to 3 minus 4x. Now solve the value of x. 3 minus y, then x equals to 3 minus y upon 4, and this will be what? Real. 3 minus y by 4, always you will get real. It means this belongs to domain. So we can say that range should be equals to codomain, because we have taken arbitrary element of codomain, and we have shown here y has pre-image. It means every element of codomain has pre-image. If it will happen, every element of codomain has pre-image, then you can say range equals to codomain. If range equals to codomain, then we can say that f is on 2. Now f is 1 1 also, f is on 2 also. Therefore f is bijective. Right? Understood?
Yes. Yes, sir.
Its second part, can you say it is 1 1?
In the second part,
Second part. Can you say it is 1 1 by looking? It is, see here, it is quadratic polynomial. If quadratic polynomial, then we know that image for 1 and image for -1, same value will get. That means it is many 1, it is not 1 1. And if you solve the value of x for some value of codomain has no pre-image in domain. So it will be neither 1 1 nor on 2. Right. Now I'm showing question number 9. Question number 9, it is very interesting question. Its length is very small, but it came 2 times in board examination as a 4 marks question. Answer 9. Here function f n to n and fn equals to, it is n minus 1 by 2. Please check your book. It is n minus 1 by 2 or n plus 1 by 2? Prince?
it's n minus 1 by 2.
Okay, correctly I have written n is even. Now we have to state whether the function is bijective or not. Bijective means it should be 1 1 also, on 2 also. By chance if you will get it is not 1 1, no need to prove on 2. So first I'm checking 1 1. Now if you'll consider 3, image of 3 will be 1 and image of 2 will be 1. So here you can say 2 and 3 belongs to domain and they are distinct. Now f2, since 2 is even, then we have to put value of n here. That means 2 by 2. So we are getting 1. And f3, 3 will put, then here you have to put that. That means 3 minus 1 by 2. So it is 2 by 2. So it is 1. So clearly 2 and 3 are distinct. 2 not equals to 3, but f2 equals to f3.
3.
Therefore f is not
1 1.
not 1 1. You have book with you? NCERT book you have?
Yes, sir.
So is it n minus 1 by 2? Once
So
again
in,
check.
so in my book also it is not given the sign.
Acha, sign, it is by chance if n plus 1 by 2, then what will take? Will take 1 and 2. 1 if you take, then 1 you will get, and 2 if you put, then 1 you will get. So it is according to questions, if by chance n plus 1 by 2 is given here, then we'll consider in place of 2 and 3, we'll consider 1 and 2. Then same images will get. If it is
Oh,
not 1 1, no need to prove on 2. Therefore, f is not bijective. But if in questions they will ask, check 1 1 and on 2. After that, if they will ask it is bijective or not, then you have to prove both. Right. Now,
Yes, sir.
last question I'm showing, that is question number 10. I hope you understood how we can prove a function is bijective. Now, see question number 10. So, answer. This also came in board examination 2-3 times. So, this is very good question. So, here function f, here a equals to r minus this, and b equals to r minus set 1, and f a to b. So domain is real number, set of real number minus set of 3, and defined as x minus 2 by x minus 3. Is f is 1 1, or and on to justify your answer. Check. 1 1 for all x1 x2 belongs to domain. If fx1 equals to fx2, then what do we get? Fx1 x1 minus 2 upon x1 minus 3, and fx2 what do we get? X2 minus 2 upon x2 minus 3. Now cross multiply and check what we are getting. X1 minus 2, x2 minus 3 equals to x1 minus 3, x2 minus 2. Then x1 x2 minus 3x1 minus 2x2 plus 6. Here we are getting x1 x2 minus 2x1, then minus 3x2 plus 6. x1 x2 x1 x2 cancel, 6 and 6 cancel from both sides. Now minus 3x1 plus 2x1 minus 3x2 plus 2x2. So here minus x1 we are getting, and here minus x2 we are getting. So
Yes, sir.
minus minus cancel. So x1 equals to x2. So if fx1 equals to fx2, then x1 equals to x2 we are getting. Therefore f is 1 1.
Yes, sir.
Now check on 2. Let y be any element of codomain. So let us check. We are getting pre-image of y or not. So y equals to x minus 2 upon x minus 3. Then cross multiply. So if we'll cross multiply, then we'll get xy minus 3y equals to x minus 2. So xy minus x equals to 3y minus 2. Take x common, y minus 1 equals to 3y minus 2. So x equals to 3y minus 2 upon y minus 1. We know that y should not be 1. Y should not be 1. So this value always will be a real number. That is, it will belongs to A. It means belongs to domain. It means every element of codomain has preimage in domain. Because why we have taken arbitrary element. So every element of codomain has preimage in domain. Therefore, range equals to codomain. This line definitely you will write, because
Okay, sir.
if range and codomain are equal, then it will be onto. Therefore, f is
Onto.
it means f is 1 1 and onto. F is 1 1 and onto. So these kind of questions I hope you will be able to solve. Now
Yes, sir.
here I'll end this video.